Hello everyone. In the previous video I've shown you how to do the pre-layout simulation by creating the test circuit for the schematic circuit which is designed, right? And we have also seen some of the analysis, that is the transient analysis and DC analysis for with respect to inverter circuit, right? So that is with respect to pre-layout simulation. So now I will show you how to. So the next step is to create the layout and to perform post-layout simulation, right? So in this video I'll show you how to create a layout for the test schematic. So in other words, from the test schematic, then how to interconnect using different layers, then what are the design rules, and we'll see other the rest of the steps. Okay, so this is my schematic circuit I have created with inverter, right? With respect to inverter circuit, right? We have successfully verified its operation, so now we can easily confidently move to a next step for the layout generation. Okay, so how to create the layout is the first thing you have to do is you have to go to launch. In the launch you have to take layout Excel, so select layout Excel. Fine, so that is the tool for creating the Excel layouts. It's create, so it will ask for physical implementation startup options. So we want to create a new, so I'll give new. Configuration I'll give it as automatic, because a lot of things has to be configured. So in this video it will be a use step, so for that I'll give automatic, so it will set up all the things. Okay, so I'll give OK. So once you give OK, another window will appear here. It will ask for library name as well as cell, so it is inverter schematic. So here you can give a name as inverter layout. Okay, otherwise it will get confused. So cell name we have to give it as inverter layout, so we want to view the layout, so type is layout. Okay, if I give OK, so inverter layout will appear. So this is another window to create the layout. So how to create the layout is, so here we are not going to create the standard cells, so instead we actually going to create uh, all from the source. So we'll go into all the standard libraries we have already, so we'll use from that only. So but only thing is you have to interconnect those things properly. Okay, so how to do that? So you have to go to connectivity. So here go to generate, select all from source. Fine, if you select that, so connectivity, generate all from source. Fine, so select that, so a generator layout will appear. So here, so it will ask what are the instances you want to create, any chains or folds. So I'll tell you what are these things. So then PR boundary, so you have to select all these things, or if you don't want to, that is also okay. Now, so minimum separation 0.21, so you can also minimize it, but based on 45 nanometer technology we have this. Then input output pins you can check, so it is already generated automatically. Then PR boundary, so it's already there. Then floor plan, so you don't have to do this, it will preserve all these things, you don't have to worry about that. So that's it. So in output pins, here you can create the pin labels. So pin label in the sense, see, in order to interconnect, it is basically a layout, so it will be very difficult. Here pin layouts will not be there, right? It will be very difficult for to design, so which one is the source, which one is the drain, and which one is the gate, right? So it will be confusing, so that's why you can create the label. So here it is the label, right? So to create a label you have options. Usually the size and height of the label will be very high, right? So one means it will give a lot of high big alphabets. for that, so instead of 1 I'll give a very small value, let's say a 0.05, so not even 0.1, half of 0.1, so that the text will be very small, so that it looks neat. Okay, so that's it. So we can create a label. It is not mandatory, but if you create it, it will be good for you to interconnect the connections. Okay, so that's all. So you have generated everything from the chain folds, everything. So except global pins, you can select all these things, it will not be problem. Then click OK. See, now it is only has generated automatically. Fine. So these are the labels: VDD, Vout, VSS as well as VIN, and this is the metal layer. This is the metal. This for PMOS as well as NMOS, it is only has created the layouts automatically, right? So if you select Shift F, so if you select Shift F, the shortcut is the Shift F, so it will give you the layout uh, pattern. Fine. See, if you observe here, the for PMOS as well as NMOS, the layout is automatically generated, right? So you can see, so it's source as well as drain as well as polysilicon. Where is the polysilicon means it is a gate connection. I hope you remember from the previous classes, so from the previous courses, right? VLSI design courses. So usually the gate will be connected using polysilicon, right? So anywhere the substrate is crosses polysilicon or polysilicon crosses the substrate, so you will have a gate formation, right? So here you can see this is the PMOS and this is the NMOS, right? So now we have to connect its pattern, right? So which one is the input? So which one input is should be connected to gate, right? So polysilicon is a gate as well as here also the polysilicon is gate. So both should be interconnected and that should be connected to VIN. In the same way, from the circuit, drain of PMOS and drain of NMOS has to be connected to Vout, as well as source has to be connected to VDD and another source has to be connected to VSS. See, so now if you observe here in this case, so here the VDD and drain and source is not defined, right? So this is it maybe you can declare this as a source or you can declare this as a source, right? So you can interconnect, you can use them either source or drain, but once you use this as a source, then it has to be drain, or once you say you have used this as a source and this has to be drain, likewise you have to use it. Fine, but initially it will not be defined because all thing has been generated from the source, you can use them, so already the connections it will show, you just have to interconnect them properly. Okay, so how to connect them is, first we'll connect V in as well as V out. Fine. So V out is connected. So V in is, so this is the gate polysilicon. Wherever the polysilicon crosses, that will be the gate terminal. So here also this is the gate terminal. So both should be interconnected because in my circuit, if you observe here, see gate and gate is interconnected. That is connected to V in. As well as drain and drain is interconnected, that is connected to V out, right? So this is polysilicon, right? So if you have a layout here, so it is correct. So substrate is crossed by the polysilicon, so polysilicon will be the gate, so that has to be connected to VN. So I'll do that. So how to connect that is, this is the PR boundary, so within that you have to create the layout. Okay, how to create this? So I need a polysilicon. Here I'll select polysilicon, right? So before that you can use this, there is an option called as DRD notify. Fine, you can select this. So usually it will give you, so because we don't know exactly, so what should be the layout width as well as height of the particular layout or particular layer. Right now I don't know what is the uh, length of polysilicon and what should be the width of polysilicon, because it is a 45 nanometer technology. Likewise, if you go for different nanometer technologies, so it will be very difficult to remember all the layouts patterns, right? So that's why, so you can select this, so this will give you the notification about, so when you're drawing that particular layout or the layer, right, so it will give you the information, so what should be the length and what should be the width of that. right? So based on that you can interconnect, so that will not give you any error. So once you go for design rule check, okay, so we'll do that first. I have selected polysilicon. Here you can go to create. In create you can select shape, so I need rectangle, so you can connect here. So you can just zoom it from here to see. So when you click on that terminal, it will only give you how those points are interconnected, right? So either you have to connect these two, but then it has to be connected to V in, right? So that is it is giving. So you can see, so it will also give you the minimum area should be how much, because I have selected DRT notification. So minimum area should be 0.02 micrometers. Fine. So once you connect on this, so it will connect, right? Now you can fix this. Now it is connected. Pin is connected. Now it has to be connected to V in, but directly I cannot connect V in. But let me connect this. So this is my V in. Fine. So directly I cannot connect my V in. Fine. So for that I need to have the contact. So via contact I have to connect. So you must remember that. So directly polysilicon and metal cannot be connected. So if you want to connect these two, you should have a contact, right? So via contact you have to connect these two pins. Fine. For that I should have the contact. Fine. So I can select that. First let me select this. Let me draw this. Let me do that first. So I have not created this. Yes. So now I have drawn the polysilicon as well as, so gate and gate is connected and I have just extended polysilicon. Now both should be interconnected, so interconnect that I need a via contact. Fine. For that first, okay, let me take this V in, where I just select this. I'll keep this out. So I need a via contact. For that again I have to go to create. In the create you have to select via. So here the through contact you have to connect it. So directly you cannot connect metal and polysilicon, right? I hope you remember this. So you have to select via. In the via, see, so metal poly, so you have to select here. Via definition you should have the metal poly M1PO, right? In order to connect these two you need to have this contact. Fine, I'll select that, just hide it, and you can place it on the polysilicon. And here if you observe here, it is giving minimum area notification, right? Minimum area should be 0.02, but we don't have that area in this contact, right? So in the standard contact pattern we don't have the minimum area, that is 0.02. For that first you have to place this and exit. So now you have to extend this, so now you have to extend this to a minimum area, right? For that, so what you have to do is first you have to select, because here we have polysilicon metal as well as the white area is also there, right? The contact area is also there, right? The connection, so because they are already connected each other, so in order to extend any particular layer you have to separate these layers first, right? That means in other words you have to flatten these layers. Each layers has to be separated. In other words it is called as flattering, right? So we have to flatten that first. So how to do that is, first you have to select this like this, select, then go to edit. In the edit select hierarchy. So in the hierarchy select last option, that is flatten. Fine. So edit to separate the layers, edit, hierarchy, then flatten. When you select that, it will ask you which are the things you want to flatten or separate. So select all the options. Fine. All the preserved selections, everything has to be separated. Just click on this. Now you can see. So all the layers are separated. Now just left click on separate. Just zoom this. So what I want is I need to extend these layers, metal as well as polysilicon, in order to have the minimum area. To extend this, the option is called as stretch. So you have to stretch this uh, side. At any side you can stretch, but this side I already have a layers, so it will give you some errors, layer separation errors. So I'll extend to this side because at this side we don't have anything, right? For that, so what you have to do is you have to go to create, then select uh, stretch option. So I think we don't have here. Yeah, here you have stretch option. In the edit, you have to select stretch, or shortcut is S. If you click on stretch, when you select stretch option, suddenly when you take your cursor on the other side, see it will highlight like this. See, if you want to extend this, it will highlight like this, or this side it will highlight like this, or this side it will highlight like this. So when it highlights, you can one left click, leave it, and extend this. So with respect to polysilicon, we don't have any area errors, but that's why it is not giving you any errors. Just extend this much, then stop it. Now with respect to metal, again I need to extend this also, metal. So I'll click on that, then I'll extend. See, now it is giving the minimum area of 0.02. As you extend this, so it will automatically disappears. So you have to extend this much, so it's not enough, so I'll extend this. So now it is gone. You have to extend this much. See, it will give you the error. So if you extend, it will stop. So just stop it. Again you have to extend this also. Okay. Now, so we are done with via contact. So now you can place this V in on this pen. You can place anywhere here. You can place here, or you can place here, anywhere. I'll just place here. Fine. Or you can place here so that you will understand. Now, so I'll done with V in. In the same way, I have to go to V out. So here in this case, you can declare anything as a V source or destination. Sorry, source and drain. Or here also you can define this as a source or drain. I'll select this as a drain because drain and drain can be easily connected, and that should be connected to V out. So here the drain layer is metal. So metal I can directly connect. That should be connected to V out, right? So a shortcut is path, or you can create here also. You can shape rectangle by selecting the corresponding uh, layer. So here you can select metal, and you can go to create and take shape rectangle, and you can collect as per with respect to its area, and you can connect it to V out. That is also okay. Or you can directly use path. So shortcut is path P. If you select path, it will automatically selects. So with respect to its area, see it is highlighting, right? So if you click on that, it will only show you where you have to connect this. You just have to drag it. See, it will automatically connects. So double click, it will connect. In the same way, I need to connect it to V out. So I'll extend it from here. See, it is connecting. Automatically it will connect. Now you can ask me, so how sir, V out is connected directly to metal, right? So because both are metal, you can directly connect it to metal and metal, right? So that is what we have done with respect to V out, right? Now drain and drain is connected, that is connected to V out. Now we are left with source. So source has to be connected to VDD and this source has to be connected to VSS from NMOS. So here I will do that. See, here this source has to be connected to VSS and this source has to be connected to VDD, right? So I'll delete this PR boundary. So for time being I'll extend this toward this side. Now in order to connect this into VDD, that is source has to be connected to VDD, means directly I cannot connect, so I have to create via. So in the via you have to create it through NVEL. So I hope you remember, right? So through NVEL, M1 NVEL has to be created. So because directly I cannot create here. Fine. So this is my NVEL. You have to select M1 NVEL. So hide it. You can place exactly with respect to this. So I'll place here for your understanding. It is also giving some minimum area error. That means some of the layers has to be extended. So I have placed. So now, so this has to be connected. Before that, I need to extend these layers because it was giving some minimum area error. So I'll select this. Again I have to flatten this. Go to hierarchy, then flatten it. So I have to select all the pins. Click OK. So everything is flattened. And if you remember this, this is, so what is this? This metal layer, sorry, this layer is, this is NVEL, right? So NVEL, so that means my PMOS should be in NVEL. If it is, I hope you remember with respect to layout, with respect to NVEL process, right? So PMOS should be always inside the NVEL, right? So that's where the corresponding layout will comes into picture, right? For that means this has to be extended and that should be within PMOS. So that means I need to extend this layer, right? For that you have to select the stretch, right? Or you can go to edit and there also you can select S stretch. Our shortcut is S directly, right? I'll select stretch. See, it is highlighting. Just select, highlight that. Up to here you have to use. Now it is showing the minimum width. That means this side I have to extend minimum width. Okay. So it is stopped the. Okay, stop here. Once it is stopped, you can stop here. Now here also you have to extend this. So I'll extend. This will also extend minimum area. So now it is showing the minimum area. If you extend, it will stop. See, stop here. Now I have created NVEL successfully, right? Because PMOS should always be inside the NVEL, right? So that you should remember. Now I need to connect this drain and drain. So VDD and drain has to be connected. That should be connected to Vout. Sorry, VDD. And I'll select path. I'll place metal here. Now I have placed the PMOS. Sorry, the source and VDD is connected. Now VDD pin has to be placed on this, anywhere on this, right? For your understanding I'll place here, or anywhere you can place here. Now successfully VDD is connected. Now we left with VSS, right? I'll select and keep it here on the on this side. Now in order to connect VSS to metal, I need to have a via, right? That means I should use create via. Here instead of VL I need to use P substrate. Fine. So NMOS is to be connected to via N substrate. So directly I cannot connect. Fine. So that means you have to place your somewhere here. So exactly, so on this. Now it is also giving some minimum area errors, right? So while I was placing, so it is also has to be stretched. For stretching this, so you have to select first, you have to flatten this. So you can go to flatten, click OK, right? Now it has been flattened. Now we can stretch. Using stretch you can extend this, so did in in well. So I have to extend this also, so there is no error with respect to this. But with respect to this area, so there is an error with respect to oxide. That means both the oxide has to be extended, right, with respect to PMOS. So this is oxide basically. See, it is showing minimum area, so I'll extend here. Now I need to connect source and VSS. So I'll select path P, so it is directly connects, right? So I've connected. Now I have to place VSS on this. That means now to correct, I need to place the VSS on this. Now I've successfully placed VSS also, right? This is the step for creating the layout. Now I have done with inverter layout. Okay, what I did first, I have connected, I have generated all things from the source, then polysilicon connected, then connected to input, then VDD is connected through metal and is connected, then VDD is connected to Vout is connected to through metal, and the VDD is connected through NVEL, so that is via NVEL contact. Then VS is connected via P substrate contact. Fine, that is done. So now we have to select, save this, then